Hello, YouTube viewers. Welcome to Scale Conference. With today's basically presentation, we have. Please tell your name.
Manas. I'm Manas, working for a company called Planet Materials. We are a startup based in Gurgaon.
So, what exactly is the problem that you are trying to solve?
Uh, so, to start with, in automobile industries, people have been going with conventional material, and it's over past, if you see almost 5 to 6 decades, there is not much innovation in the material side. People have done a lot of re-engineering, but no one has gone into reinventing the material, especially from the Indian scenario. And if you just look into the aerospace and defense application, the maturity of the composite materials, uh, it has come from using something like 30%, 40% in an aircraft to 70, 80%, 70% by weight composites, by volume composites in the aircraft. So, what had stopped it from incorporating into automobile sectors? So one was the first, the composite itself is not scalable in terms of manufacturing. Second, because of
Okay,
this
stop.
problem,
When you say it's not scalable, what exactly do you mean?
so if you just consider the volume, so a Boeing may be producing like few hundreds of aircrafts in a year, but a company like Tata or even Tesla or BYD, they have to produce like millions of vehicles in a year. So these numbers are drastically differ in aerospace and defense from what they do it in automobile sectors. So whatever you make, whatever you develop, it should be scalable to that extent. Now, if you look at the composite materials, the entire cycle to produce a composite part may take few hours, and from there it may take also for several parts it may take few days.
Okay, so it's not as rapid as like taking a sheet metal, stamping it, and done.
Yes, no, it's not. So, but you want to utilize, there is like, a good amount of properties and the leverage of using composites in automobile. But that limitation is stopping it from, getting, applied in automobile so vastly. So you see, people have been using SMC and BMC kind of composite products in automobile, but it's not very common. There are limitations with respect to the strength. So we want to bring the composites which are having aerospace kind of properties, but the cost which is very effective and in tune with the automobile sector. So we at Planet Materials Lab are trying to innovate those kind of materials, and we work right from the starting of chemistry to incorporating the technical textile technologies, and then converting it to the product design, and then finally the working product models.
Okay, so the idea is to make something like this.
Yes.
And can you specify why do you have a composite rather than just having, let's say, plastic itself?
So if you just look at the plastic material, the strength of the plastic will be in like few megapascals. The modulus also itself will be like, it will be like around 2 to 3 megapascal, gigapascal range. But the moment you add a reinforcement like a glass fiber or a carbon fiber, in our case, we have chosen to go with the glass fiber because the cost you get is very, very comparable with the aluminum in the market, which we have today. So the moment you add these glass fiber, and you have advanced the material properties, the strength comes around like 400 MPa. The modulus could be as high as like 25, 30 GPa with glass, and if you go with the carbon, it can be as high as maybe like 150, 200 for specific grades of carbon fiber. But yeah, that's the advantage. Rather than using a neat plastic, you always have you add the fibers which reinforce and it strengthens your material.
Okay, so when we are talking about adding fibers, the most thing people think of is carbon fiber. So
Yeah.
just give us a rough overview, what exactly is carbon fiber?
So yeah, carbon fiber is basically you have a structure of carbon which is chained together, and then you are trying to basically you are converting a particular set of polymer to a fiber, and when you have a very high carbon content in that polymer, you get a carbon fiber. So there are like only a few methods to convert few selective polymers which are available in the market, and then you convert it to glass carbon fiber. But the process to convert a carbon fiber that gives you a very high strength and modulus is kind of very, very costly process, and that's what adds to the cost of carbon fiber. So generally in market, a good carbon fiber which is having a strength as high as like 3000 MPa, and the modulus could be as high as 150 GPa, will be available at the cost of 3000 rupees, 4000 rupees per kg. Now, the moment you start adding resin to it, the matrix to it, and you do processing, You again add the cost on it. So the overall product cost itself will come to around like 5,000, 6,000 rupees per kg. So since we are giving a solution to the automobile sector, we want to keep the price in control. We want to compete with the conventional material which are there in use for like a century, more than century. I'm talking about the steel and aluminum. Aluminum is not so common. It's common mostly when you are going to the coastal areas, but steel is something which is dominating the market everywhere.
Yeah. Basically, we measure a country's productivity by how much steel they are manufacturing. So it's a
Yes.
very what we call backbone technology we have to understand. So if I understand this correctly, what you are making here is basically using, instead of carbon fiber, glass fiber, and
Yes.
instead of using epoxy,
We
you're
are
using
using
plastic.
plastics.
Okay, just an overview why you downgraded these two things in order to achieve what you're looking for.
So okay, so it's bit of kind of optimization process and trade-off process in the design. Now you look at the thermoset like epoxies. There is a curing cycle involved, and there is a pre-processing where you start, you do wetting of the fabric or wetting of the fiber, and then you do the curing. The curing cycle typically can vary from 3 hours, 4 hours long, and for many cases when you go for a very specific requirements in aerospace and defense, it may be like more than 12 hours of cycle.
So you're talking about, like, basically not only you have to have material, but you also have to have time to cook the material.
Cook the material,
Yeah, basically,
yes.
it's not like, okay, here's the material, machine it and go.
Yes.
You make it and then you lay it over, properly wet it. Basically, it's a bespoke material,
Yes.
fine for rockets and aircraft, which you are making barely hundreds a year, rather than car, which you may be making 100 a day.
Yes, and the second problem that one another problem that we solved by making this material is the indigenization. So carbon fiber in India we don't produce. We basically buy it from outside. There are countries like Japan, US, Korea, China. They produce carbon fibers and we bring from there and then we convert it to product. Here we can easily have the technologies developed for making polymer fibers, glass fibers, and then convert it to the nice product. So we don't have to depend on outside world. We can do everything indigenous, and that's what we are doing also. We are also working on textile technologies to develop and convert these products to fabric.
Okay, let's say you made this. What are the pros and cons of this over normal steel that people will use for their shipping container and all that?
So if we start with first pro, I'll talk about pros first. Advantages: lightweight in terms of, if you just see the density, steel comes around 7.8 gram per cc. This will be around 1.4, 1.5 gram per cc. And if you compact it more, you can achieve something like 1.6, 1.2, 1.8 gram per cc. That makes it almost like, one third or one fourth lighter than steel. Strength wise, if you see the yield of steel, it maybe, if you have very good grade of steels, it may be like 600 MPa. This gives you a tensile strength of around 400 MPa. Kind of less, but comparable given the kind of applications you are looking into. This another advantage for this is it will survive a good fatigue cycle.
Yes.
It will have a tailorability in terms of design. So I can tailor it by changing the fiber direction. So this is the known advantages of composite materials, that all together, and the plastic, because of the plastic, I am able to produce it faster. Disadvantages side, it will not have the same rigidity as steel. So if you look
When
at,
you're talking about rigidity, are you talking about stiffness, or you're talking about like the whole structure?
I have to start with basic material property, stiffness.
Oh.
So if you just look at the Young's modulus of steel, it is around 210 GPa. But for this kind of materials, you will get around 20 GPa, or if we work on it better, we can achieve something like 25 GPa, 30 GPa material.
Okay. So there are some compromises when you are going from steel to this. It's not like,
Yes.
there is no side effect. There are some side effects. But the primary advantage that you are going to get is weight saving.
Weight saving, yes.
Which for transportation, because it's an energy intensive sector, it translates to a lot. It does not matter whether it's a battery vehicle, because at that point, you get more range. If it's a fuel vehicle, you get better mileage.
Yes,
So in
of
both
course.
scenario, it's something that people will notice day one. It's like,
Just to give you an example, to add to your points, if we take a 10 feet container where the weight with steel will be around 350 to 400 kg, we are able to produce with this material that same container in the range of 180 to 190 kg. So that is almost 50% weight reduction.
Okay, so weight is one of the primary advantage that you are going to get if you switch to this. And now talk about certain things that we have to, like, we take for granted when you are talking about steel. We never worry about the fire resistance of it. And again, if we are talking about battery electric vehicle, fire is a thing that people have to worry about. So how does the fire resistance of this hold up? And what about ultraviolet? Whenever you're talking about plastic, that's the biggest weakness
Yes.
plastic has. Ultraviolet breaks the long chain into smaller one. So how does this hold up?
So there are some chemicals which are used as a filler or additives to these materials. So when we prepare the polymers for making the plastic material, we can blend in those FR graded materials and UV resistance materials, enhancing the properties and giving you a somewhat extended life for this.
Okay.
So steel also has a negative side where you have to do routine maintenance for the steel. It, like, if you go with the cheaper version of it, you have to do, it's a corrosive. You have to do rust,
Mitigation,
processes, rust mitigation. Yeah. But here you have this, materials which will not rust, which you don't have to maintain much. It doesn't ask you for, any sort of paint application. You can use it as it is. You want to add paint for aesthetics, but not for the maintenance sake.
Okay, so biggest advantage you get is lightweight, and it is very environmental resistance, as in like heat and cooling cycle will not expand contracted too much.
Yes.
Rain does not matter.
Yes.
And basically you can make a container ship that goes into the sea, it still does not care.
Yes, all salty and marine environment can
Basically,
be,
you can make it waterproof without paint and it will still be functional.
functional. Yes.
Okay. So I'm getting lightweight structure and I'm getting an environmentally resistant material.
Yes.
Although I am compromising a little bit here and there, like a bit of stiffness and fire resistance, these sort of things.
Yes.
You are compromising. But because given the fact that we are talking about a vehicle, lightweight is much higher part. Now talk about like the fact that you are making it into basically two structures. You have plastic here and you have glass fiber here.
Yeah.
So what unique advantages you have when you combine these two rather than any other two composites?
So plastic gives you somewhat more flexibility compared to thermosets. If you see the strain wear failures for these materials, you can actually extend it, like, it will be much more higher than the thermoset values. It can be as high as, like, 6%, 7% strain values.
Okay.
So which is quite good, and it gives you some sort of flexibility. So combining these materials, one, it's cheaper. Glass and plastic itself, whether it's nylon or it's the ABS, it gives you a cheaper cheaper option. You are able to tailor the properties by combining it into different form. When we do weaving ourselves, when we make the filaments, we can control the properties at the filament level to tune the final properties of the product.
Okay, just describe that. Like, what do you mean by tailoring the filament that is going inside? Do you mean the diameter? Do you mean the stiffness of the fiber? What can you tailor?
So basically, there is this parameter called tenacity for the textile. So it's basically nothing but the strength in terms of linear weight. By controlling the diameter as well, I can, if I have higher tenacity, by virtue of it, I will get a better strength without increasing the weight of this product. So if I can, like, have a lower aerial weight of the fabric, I get the same strength.
Okay. Okay, let's talk about one thing that is becoming more important as global warming proceeds is the insulative property of this. So how does it compare to aluminum or steel?
So with respect to steel and aluminum, it is almost 1/10. Its conductivity, thermal conductivity property is 1.2 watt per meter Kelvin. If you just look at, I think, steel or aluminum, I think it is like around more than 12. And so if you put it as a refrigerated, structures, it will do a good job. We can combine this with foam, maybe a PU foam or some other porous structures, which will again give you advantage reducing the thermal conductivity. So I can have the entire refrigerated vehicles, refrigerated structures made out of this with the addition of PU foam as well, and not compromising my weight.
Okay, so not only I'm saving on weight, but I'm also saving on refrigeration cost itself.
Yes.
Because sunlight will not be able to conduct very well.
Yes, you can increase, you can reduce the thickness of this material to have a outside panel, so you get much more higher volume efficiency for your storage tanks.
Okay, one important thing. This is a sheet material that you are working on. Like, can you make structural material out of it?
Yes, we can mold it to different shapes. This is one example of it. We are working on pultrusion technology as well.
Can you show that example?
We don't have right now. So this is basically a pultruded beam made out of thermoset, but this is not thermoplastic. And thermoset pultrusion is kind of common, and people have adopted this technology in India very well. But no one has worked on thermoplastics. So this is something that we are working on. We are trying to work out a solution with thermoplastic material pultrusion of design shape.
This sounds almost like metal.
Yes.
So how close this is to, let's say, a steel beam?
It's strength-wise, it will be very in par.
Okay.
If you compare it with the yield strength of the steel, modulus-wise, it will be slightly lower on the lower side.
And weight?
Weight will be almost 1/4 of the steel.
1/4, as in 25%?
Yes, because the density of this one is almost 1.6, 1.7.
Oh, so if you make a vehicle structure like a C-channel frame that we use for trucks and all that, so not only you can make a structure that is heat resistance, because again it's not absorbing it too much, and this can also reduce weight. So you can have exponentially lighter vehicle while having the same payload capacity.
Exactly. And we had done a proto also, and we had demonstrated by doing on-road testing, where we had replaced the entire metallic frame, including the chassis, with this material, even the support structures, and we tested it perfectly. It worked very well, and we were able to reduce the weight of the entire vehicle by almost 45%, 45 to 50%.
Okay, so that takes care of like what is the science behind it. Now talk about your business. So what are you trying to do? Like, are you business to business? Are you business to customer? What are your goals?
So right now our strategy is business to B2B, catering to mostly logistic companies. We see a lot of advantages. Either you are doing intercity or intracity, you will have the advantage. Either you carry extra weight, or if you are a EV, then you can definitely have extra range. So given those advantages, we pitch it to the people who are into logistic businesses. Just look at our products, and people also who are making these kind of trailers. For them, we can have a material where these materials, you can have lightweight structures, you can have faster manufacturing, you can have a better insulation from outside. So all these advantages, like, people should be exploring our material.
Okay. So how can people find you?
So yes, we are available. We are called Planet Materials Lab. You can go to our website, planet.matlabs.com, and you can go to any of our team members. Contact details are available. You can contact us, send us mail. We will reply you within very short time.
Yeah, so this was a very unique company that is trying to make something that is effective on your wallet. Not only effective for the planet, because what's the point of a magic if you can't afford it? So he's also making something logical, and made in India is also a very desirable thing. So I think this technology can expand a lot, right? You do not have any constraint like this magic material or neodymium or something like that. You have like flexibility of expanding.
Yes, we do, and we are hoping to expand a lot. We don't see any limitation on one, our know-how technology. Second, the supply chain. We don't see any limitations or bottlenecks there.
So let's just say your company gets a cash injection, you can actually expand with it. You won't be like, okay, we got it, now how do we scale up? You do not have like, okay, this mineral is imported from China, this is from Germany. No. You don't have that issue.
Yes.
So basically you are in a very unique position where you can scale up. You do not have to worry about it. You're like, bro, I got this. Like, you have a requirement, we can supply it.
Yes.
You no longer have the issue. Okay, so this was a very interesting talk with Mr.
Manas. Hi.
So Mr. Manas, we had a very interesting talk. I hope you guys have liked it, and please follow up with him so we can see what more interesting things he can make in the future. Bye.
Okay, thank you.